Okay. I think we're approaching 2:30 here, Helsinki time, and it's time to start the webinar. I want to warmly welcome you all to today's Industry and Society webinar organized by the Finnish Center for Artificial Intelligence. Now, today we're going to talk about empirical design of experiments with AI, which is a very fascinating topic. My name is Mikko Mäkelä. I work as a research professor in intelligent biomass processing at VTT, and I'm going to host today's webinar. We've been fortunate enough to manage to rally three excellent speakers for today's webinar. We have Arto Klami from Helsinki University and FCAI, and then Morten Bormann Nielsen from the Danish Technological Institute, and finally Søren Furbo from Novo Nordisk. But before I let these gentlemen deep dive to the actual topics, I suspect that we have some international guests or other guests who might not be that familiar with FCAI. So I'm just quickly going to present who we are, what we do, and then we'll jump into the actual webinar content. So FCAI is actually a flagship project funded by the Research Council of Finland. We started off in 2019 and continuing until 2026. So we actually focus really on fundamental machine learning and unsolved machine learning problems. I think this figure nicely summarizes the structure of FCAI, where on the left-hand side, you see the fundamental research programs, which are mainly led by university professors and focus on data efficiency, trust and ethics, and understandability of AI. And then on the right-hand side, you have the application domains. An example here is our highlight programs, where we have an AI-driven design of materials highlight, which I, for example, coordinate together with Milika Todorovic from the University of Turku. We are very active in building collaborations in Finland and abroad. We actively work with also other Research Council of Finland flagships, for example, the FinCERES Materials Cluster. Then also key research partners from abroad, many different kind of companies in Finland and internationally, and then finally also the public sector. What I want to highlight in this slide is actually our collaboration with the European, with the ELLIS network in Europe, which is actually key at the moment because we are working very hard to establish an ELLIS Institute in Helsinki. So ELLIS stands for the European Laboratory for Learning and Intelligence Systems, which is actually a pan-European network of units and institutes that focus on AI excellence in Europe. A couple of these units have expanded to institutes in Europe. The first one was Tübingen in 2023, and now the second one will hopefully be established in Helsinki in the years to come. We're now actually on the ramping phase and hope to get full operation in 2032. I just wanted to quickly mention this because I think it provides a lot of benefits for different kinds of actors in Finland and also in Europe. And you can actually just find more information in the FCAI website given there on the slide. My background is partly in chemometrics, and I just want to provide a quick historical context for the idea of design of experiments and using AI and machine learning for the topic. Design of experiments is actually an established methodology in the traditional statistics and chemometrics field. We generally have two different objectives. One, on the left-hand side of this slide, we might be interested in mathematically quantifying and comparing the effects of different factors, here meaning experimental conditions on our measurements. These ideas were first laid down actually by Fisher already after the First World War. We normally focus on just a couple of different levels per variable, and the research is often more fundamental, and it might be difficult to describe a clear mathematical objective. And then the second objective on the right-hand side is optimization. This was actually something that was originally started when chemists started working with statisticians in the 1950s. In the traditional DOE methodology, we normally use linear and deterministic quadratic functions with, say, 3 or more levels per variable. The focus is, by definition, more applied, and it's easy to mold it into a mathematically defined objective. Now, this optimization part, we can nowadays then replace with AI, which is one of the core topics also of this webinar.